Alright, so we stopped here, and now we will go over step number 7, where we will deploy the best model based on our results that we saw here. So it is neural network, and actually what we can do here, since we have decision tree, we can also do the view tree. That way we can see the decision tree. So as you can see here, it's a really nice model that will show us the absence. For example, let's look at the absence of coronary heart disease. So this map or tree can tell us that tobacco intake level is a major variable that helps us kind of predict or classify the absence versus the presence of coronary heart disease. So it tells us here if the tobacco intake level is equal to 1 or less, so basically low. So we have 3 levels: low, medium, and high. So if it is low, meaning 1, then 86 of those of the patients in this set will not have coronary heart disease, right? And then based on age range, so if the age range is, let's say, young, in this case, so 98% of those patients in this, they will be classified as not having heart disease or coronary heart disease. So this is basically how we read the decision tree, right? So now what I need to do is to deploy or test with new data. So test our model with new data, and to do that is we need to go to evaluate, and then we will have the prediction. So the prediction is we will need actually to have a new data set. So in this case it is a file. I'll have this file here, and since I already have it here, I have the sheet to be predicted. It is here for us. So it has this one. Now it shows age range as categorical. I need to change it to numeric. Alright, I'll say apply. Alright, so I'm gonna use those variables here to predict and to see how good it is going to do, and then I will select connect my prediction models here. Alright, so now let's run it and see. So absence based on the decision tree. Logistic regression tells us it is absent, present, absent, present. So basically this is, it tells us what are our expectation or our prediction classification. So the first patient, based on that data that we provided, it is predicting it. So this one, oops, let's see, to be absent. Alright, because 0.52 absent and only the presence is 0.48. So you get the idea now. Now if we have new data, it will classify it based on those models that we have. Alright, so that's all that I wanted to cover, and then I will add one more video for predicting continuous variables.